Welcome to After Hours with Dr. Sigaloff, where he can share ideas and thoughts with you. He gets to the heart of the issue so that you can find the truth. The views and opinions expressed are his and do not represent the U.S. Army, DoD, nor the U.S. government. Dr. Sigaloff was either off duty or on approved leave, and Dr. Sigaloff was not in uniform at the time of recording. Now, to Dr. Sigaloff.
All right, well, thank you for joining me again. I want to first thank all my Patreon supporters. We've got Shell at the $50 level, Sam and Angela Shelkey at the 2020 level, custom-made level at the Pandemic Reprimando, $17.76. We have Perry and Ty. We've got Kevin Alanos and Katie at the $10 level. We've got Joe, PJ, Rebecca, Emmy at $5. And at the $1 level, I want to thank Amanda, Spetsnazdy, and Jay. Thank you so much for all your support. Don't forget, I'll be selling more of these patches. And those will be available too. But today we have a very special guest. And what's great about today's guest is he is a physician. He's actually in residency right now for neurosurgery, which is like among the surgeons in the medical field. Those are guys, they're like the fighter pilots. They are the cream of the crop type of doctors. But he's also an advocate. He thinks it's a good way to live, is the best way to put fuel in your body is to use what we call carnivore, or also what man ate 10,000 years ago, and we've forgotten that since. He's seen amazing healing with it, just as I have. And the reason I wanted to have him on today is, you've heard me talk about it, I can go on and on and on about it, but to hear a different perspective, someone else talk about it, I think it gives more credibility to this way of eating. So, how you doing today, Dr. Chaffee?
I'm doing great. Thank you very much. Thank you for having me on.
And just call me Sam through this whole thing. But give us a little introduction of kind of your story a little bit, and how you stumbled across the whole carnivore diet, and what led you to believe that is probably the most appropriate way for humans to eat.
Sure, and please call me Anthony, of course. I'm an American doctor. I'm doing my residency in neurosurgery in Australia, as you mentioned. I have always been interested in diet and nutrition, how that affects the health and performance, especially as an athlete. I was an All-American rugby player, and then played at the top levels in the US and Canada, as well as at the professional level in England as well. And have always loved sports, always loved competition, and wanted to fuel my body the best way that I could. And so obviously nutrition is the best way to do that. So I've been studying nutrition since I was a teenager at a university level. When I was in my undergraduate degree at the University of Washington in Seattle, I was taking cancer biology, and we were learning basic fundamentals of biology and botany, which is that plants use defense chemicals in order to defend themselves. They're stationary, they can't run away or fight back, and use the other sort of kinetic defenses that animals and other species have. And so they have to have other defenses. And one of those defenses that is ubiquitous amongst all plants are defense chemicals and poisons. And we were looking at this from a cancer point of view, so we're looking at carcinogens. And we learned that, this is 22 years ago, that Brussels sprouts, they'd already discovered 136 known human carcinogens just in Brussels sprouts, and over 100 just in mushrooms, and spinach, kale, lettuce, celery, cabbage, cucumber, broccoli. All of these different plants that you would find every day in the produce aisle would have 60, 80, or over 100 known human carcinogens each, and they were quite abundant. We have research out of UC Berkeley in the 1980s from Professor Bruce Ames, looking at the defense chemicals in comparison to the pesticides we use industrially, right? So these defense chemicals are actually the natural pesticides, the natural insecticides that the plants use to stop pests and insects from eating them. And then we add to that, because there are some animals and insects that are immune to those defense chemicals, but they're not immune to other defense chemicals. And so we add something to the mix to make it cover different species. And he found that just the defense chemicals and carcinogens that he found in these plants at that time, which weren't as many as we've discovered since then, were 10,000 times more prevalent by weight than the pesticides we sprayed on them industrially, and that the naturally occurring ones were 1,000 times more likely to cause cancer than the pesticides we sprayed on them in animal models. And specifically, they were looking at alar in this instance, which was a pesticide they were spraying on apples. And so this is why we still have pesticides.
So you just said that the the naturally made, this, organic, if you will, made by the plant toxins that it uses to protect itself are more carcinogenic than the stuff we spray on it.
Yeah, and that's why we still have them, because they were actually trying to get all these pesticides banned back in the 80s. They actually did ban a number of the different pesticides that we used to use, because they said, oh, these are poisons, these are toxic, these are horrible, and it's true. But Professor Ames showed that actually the natural defense chemicals in the plant itself are actually worse, which would make sense. There's standard reason, because these things are alive. They like to stay alive, and all living things have a defense. And so they have to have these naturally occurring pesticides and insecticides in them that are basically poisonous to everything on Earth, except there are a few animals and insects that have evolved to break down these specific defense chemicals break them down safely so that they can eat them. And, they have that defense. So as you learn in basic biology, plants and animals are an evolutionary arms race. Plants becoming more and more poisonous, so less and less animals can eat them, so they can survive and thrive. And then animals becoming more and more adapted to specific poisons in specific plants, so they can eat that plant and survive and thrive, and that is their dedicated food source. Like a wallaby in Australia, people marvel, is like, wow, these things that they eat are just so deadly poisonous to everything else. That's amazing. No, that's actually very normal. I mean, think of the eucalyptus and koalas, or bamboo and pandas, and other animals. Some animals eat bamboo as well, but all of these plants that they eat are generally going to be toxic or even deadly to basically every other animal on Earth. So if you think about it, all plants are poisonous. It's just that certain animals have evolved the ability to break down specific poisons in specific plants. But if they haven't evolved to eat that plant is bad for them. And that goes for us as well, because of course we live within nature, and we can't deny our place in nature. We did not come here from space. We did not flash out of nowhere. We are part of nature. We are animals, and nature applies to us. And if we deny that, we're just doing that at our own risk, because reality will win every time.
So Anthony, this is exactly what just caught my attention. I was listening to you I think you came up on my Instagram feed, and you said a phrase that I've been saying you've probably been saying it longer, and I never heard it before from any other doctor, but I said it for 2 years now, and it caused a lot of problems for me. But I said, plants want to kill you. They don't want you to eat them. They can't defend themselves. They don't want you eating their babies, and their babies are their seeds. I don't think you said that part, but their babies are like their seeds. And when I heard another doctor say that, I was like just blown away that, wow, someone else came to the same exact conclusion. And so that leads me to the next question. Well, Dr. Anthony, what else can I eat? What did humans eat 10,000 years ago? What's on every continent in every season that's available for food? Except for Antarctica, but nobody lives there.
Well, penguins, eat some penguins. But yeah, but you're right. I mean, that's exactly it, is that, the universal underlying theme there is animals. We were hunters. We were not hunter-gatherers. We were hunters. We were very recently hunter-gatherers after the megafauna died out through some sort of cataclysm or overhunting, probably a mixture of both. And at that point, we had to sort of find other means of sustenance. But, even then, many civilizations still were exclusively eating meat. When the Europeans came to America, they were essentially all of the native peoples were still just carnivores. They were doing buffalo drops. They were just scaring part of a herd of buffalo over a cliff. They'd all fall down and die, and they would make pemmican out of that, dry the meat, crush it up, and mix it with rendered fat, and that would last the whole year. And that's all they were eating. And there was 100 million people on the continent of North America surviving like this. And there were certain areas that developed agriculture, actually 7 independent places across the world. So it seems to be that this provided some sort of advantage in certain areas where maybe we didn't have big buffalo herds and things like that. But there were plenty of peoples. I mean, think of slightly further back than that, Genghis Khan and the Mongol horde. They were pure carnivores. They just ate horse meat, drank horse blood, and fermented mare's milk and their products. And they're completely lactose intolerant, by the way. They didn't actually just drink it on its own. They had to ferment it and get rid of all the lactose. It was always fermented, like cheeses and yogurt and like a little weird beer. I don't know how that's going to taste, but it's like mare's milk booze, and that's what they ate. And it's actually conferred huge advantages to them, not only in health. These guys were huge. I mean, every account talks about this, how they were just that monstrous in size. These guys were pushing 7 feet, and it was massive people. And they would talk about how they wouldn't eat for 5 days in a row, and then they would eat 5 pounds of horse meat, 10 pounds of horse meat in a go, and then they'd go for another 5 or 6 days. And that was normal for them. And because of that, they were much better nourished, they were much stronger, they had much better energy, and they didn't have to stop 3 times a day to get out the field rations, boil up some oats, and feed all the troops, and then keep marching. They could just keep going, and they didn't have all these cook fires and campfires and everything like that. So they were silent. You couldn't see campfires and army. There's an army. Oh, it's coming closer. Oh, we know where they are. You didn't know where they were. They just show up out of nowhere, and they knew exactly where you were because they could see all your campfires. They could see you stopping 3 times a day, and they could see your campfires at night. And so they had a massive advantage, and they took over most of Asia and most of Europe, and they had the largest contiguous empire that's ever existed, and they held it for hundreds of years until there was another cataclysm that seemed to get up a bunch of particulates into the atmosphere, block out the rays of the sun. A lot of the plant life and grasses died off, and horses just aren't as capable of extracting nutrients out of grass as cows are. So the peoples that were nomadic cow herders, they sort of took over, and that's what Russia is now. They took over most of that previous empire, and but that just goes to show you that this is a very, very viable model, even for a large empire, and actually it confers an advantage to that. We've sort of forgotten that. But there are a number of examples of that throughout history.
Yeah, what I think is interesting is there's this idea in the medical field that the Mediterranean diet that has been, allegedly proven to be so heart healthy, they've turned it into this plant, monstrosity where it's, we're just eating plants. But if you look at the people in the Mediterranean, they ate goat's milk, sheep. They had some fruit like olives and, cucumbers and tomatoes. And cheese and yogurt, but it was a animal-based diet with fruit. And can you get into the difference between, sorry, go ahead.
I was just going to say, read the Iliad and the Odyssey. It's all about, the animals that they're herding and, sacrificing goats and sheep and things like that. Odysseus gets back home, kicks out all his suitors who are just every day, they're just, decimating his herds. And they're like, and he's telling his wife, he's like, don't worry, we kicked all these guys out. We'll get all that money back. We'll just, go start raiding their towns and villages, and we'll just take it all back and things like that. It was all about meat. It was all about animal produce. Yeah.
And I don't know if you have any sort of a religious background, but in the Bible too, it's about herding. He was a wealthy, like Abraham was a wealthy man because he had huge herds. And yeah, it's when you start looking back, you're like, everything points to eating meat.
Well, yeah, to your point there, look at the story of Cain and Abel, basically almost as far back as you can go. We're not in the Garden of Eden anymore. That's when people think it's like, we can eat all these plants. No, we're not in the Garden of Eden. That's the whole point now. And so we are, subject to different rules. And Cain and Abel was a herder, and he sacrificed, the fatted lamb to God. God was pleased. And then Cain was a farmer, put up some crops on there, some tofu and bean curd, and God was like, absolutely not, that's disgusting. And then God was displeased. And so, and then Cain got, very, jealous and butthurt about that. And so he ended up killing his brother Abel, which I think is the first example of an angry vegan, just like, I'm not happy with you meat eaters. And, but yeah, there are plenty of examples of all of this.
I watched this cartoon on YouTube with my kids. It's called Storybook. And some of the older versions of it, they have that Cain and Abel story. And it's so like right in your face. They did a very, very good job of it. Abel is this herder, he's eating sheep and eggs and all this, that, and the other. And we call it strong food for my kids. And we have weak food. Weak food is, any vegetable and all processed foods. Fruit's kind of in the middle, doesn't really matter so much. And what's just striking, I asked the kids, what's Cain eating? Weak food. He's eating grains. He's eating like kale. He's eating spinach, and he's eating his brother brings him eggs. And this is they've taken some literary license with this, right? His brother brings him some eggs, and he smashes them on the ground. And it's just like, wow, he didn't eat any strong food. I don't know if you remember, in April of 2020, there was an article that came out that said that those that eat meat have less behavioral health issues than those that eat no meat. Well, what's a murderous rage? That's a behavioral health issue.
Yeah, absolutely. And I was just thinking of what you were saying. That's interesting that you have that same conclusion that plants are trying to kill you. I originally heard that from my cancer biology professor, because that's what he said 22. That's what converted me 22 years ago to exclusively eating meat, was that he said, basically telling us about all these carcinogens and toxins that are in vegetables. And literally we were blown away. And I remember I was looking around wildly to see who was in on the joke, because it must be a joke. And everyone else was doing it too. Everyone was just looking around, just violently, like, what's going on? Just looking for like a TA, someone in the corner, just laughing, like, he just always does this. No one did that. Yeah, exactly. And we're on candy camera or something like that. And like, it didn't happen. And so it just sort of dawned on me, like, okay, this guy's serious. And I remember thinking to myself, I'm like, but vegetables are still good for you though, right? And he just sort of looked at us. He just read our minds, and he just said, I don't eat salad. I don't eat vegetables. I don't let my kids eat vegetables. Plants are trying to kill you. So I was like, right, forget plants. And I just stopped that day, and I just, went to the store. I was looking around. And my only mission was to not eat plants. And I was looking, like, what else is there? Is everything's plants, or it has plants in it as ingredients? And so I just came across, eggs and meat and milk. And I was like, oh, okay, these don't come from plants. So that's all I'll eat. I was still drinking milk at that time. I don't really anymore, just because it has enough lactose that it can raise your insulin and derange your metabolism. But at the time I wasn't actually drinking all that much that often. It was mostly just meat and water. But yeah, but that was my only I thought was, like, I don't want to eat plants. Plants are trying to kill me. And I just got rid of them. When I was in England, I was playing rugby over there. It was just harder to get meat, and it was much more expensive. A lot of it was breaded, and just for convenience, I would get some of the breaded meat, and just because it was easier. And I don't know what it was, but it was very hard to cook a steak over there. I don't know if I can. This pisses off everybody in England every time I say our meat's such good quality. I'm like, okay, maybe, but the ones I was getting was injected with water or something, because I could not get these things to brown at all. It didn't matter what heat I used or how long I cooked it. It was they would not brown. And so I'm cooking it. It's just being gray. I'm like, what is going on here? I flip it over. It's just gray and sweaty, and it would be completely cooked through. It would be completely well done. It would not be brown on either side. I was like, what is going on with these steaks? Couldn't get these things to brown. And so, I just, for convenience, sort of went for these pre-cooked things that were breaded. And I was like, well, is that going to be a problem? I was like, well, dose makes the poison, so maybe it's not all that bad. And you're always able to convince yourself of some stupid idea that you want to do. And so I did that, and I actually didn't feel as good. I remember a couple months into it feeling like, why don't I feel as it's absolutely just superhuman amazing as I normally do? Am I not working out as hard? Am I 25 now, so am I over the hump, and am I just dying now? I don't know. I didn't know what was going on. But it was looking back, that was exactly when I started introducing plants back in. And the worst thing that did was it changed from me really thinking I'm not eating plants at all ever to I guess they're not, I guess some of these things. And all of a sudden I just started eating these things. I remember one day I was with the team, and it was like a Sunday or something like that. And we're all just hanging out, and I was like, oh, we should make French toast. I haven't had French toast in years. And I was like, I wonder why I haven't done that. Just completely forgetting that I've not eaten plants in 5 years, And it was so weird. It was so weird. I just, it just sort of slipped away, and I just sort of lost that thought. And then sort of 5-6 years ago, I came across, again, information that, no, humans actually are carnivores as a species. That's biologically what we are. We are animals, and the type of animal we are is a carnivore. All animals have a species-specific diet, very specific things in the wild. This is why there are signs at the zoo saying, do not feed the animals. This will make them very sick. Signs at the park saying the same thing. And that is why. Because if you eat something that you're not designed to eat, you will get sick because of these defense chemicals, and because you can't process the fiber and the carbohydrates unless you're a certain species. And we are not that species. And so I looked at that and I went, right, I knew it. I knew plants were trying to kill me, get rid of these stupid things. And I just went back to just eating meat. But now I was doing it in a much more mindful way. I knew exactly what I was doing and why. And then I really started digging into the research and the data and asking, okay, what do we know? And what can we prove? You know? And I just started digging in. I basically left my residency at the time to go help with a family emergency. My parents were having health issues and I just needed to be home for a while. And so I was helping out with that. And so I had a bit more time. And so I was literally spending just 8-9 hours a day. I was back doing my boards and MCATs again, just like in front of a computer, just reading and reading and reading. But now it was just trying to research, asking questions like, okay, like with sugar, has that been causing, I knew sugar, I knew the research about sugar and fructose and that causing harm. I knew the research that, cholesterol and saturated fat actually weren't bad ever. And, so I had all these things, and the plants are trying to kill you sort of things.
That's a mind-blowing thing that cholesterol is good, saturated fat is good. Our body's made of it.
That's it. Well, yeah, well, that's it. I was in 8th grade and was taking, biology in 8th grade. And I remember learning it's like the cell membranes are cholesterol. And I was just like, I remember thinking to myself, I was like, how is cholesterol bad for us? We are cholesterol. I was like, well, I'm just a kid. I don't really know everything. So, I guess I'll learn this eventually. And I just sort of tucked that thought away. But, I was right. I mean, that's why, they talk about, like wisdom from the mouth of babes, because, kids haven't been indoctrinated yet. And they can actually just see what's in front of them. It's pretty damn clear. Like, we are made out of cholesterol. Our hormones are all made out of cholesterol. Our brain is made out of cholesterol. There are a lot of things that run on cholesterol. Why would it just all of a sudden be bad for us? Or, the carrier protein, more specifically, that transports fat and cholesterol around. Why is that bad for us? That's a natural process in our body. And just for some reason, it just... Yeah, exactly. And so this is where we vilify LDL cholesterol. First of all, there are many different kinds of LDL cholesterol. They're not all the same. But again, this is a natural, normal molecule that we make in health to transport lipids and cholesterol. Why would that be bad for us? That doesn't make any damn sense.
It just shocked me when I was in biology 1301, and they said, if you go on an extremely low caloric intake, your LDL and your just skyrockets immediately. I was like, that is a strange thing. Why would my LDL skyrocket why would my body make something to kill me if it's as bad as they say it is when I'm fasting? And then, 20 years later, I find out, oh no, it's part of the immune system. It helps scrounge up all that stuff. It's a way to move energy around my body to where cancer and bacteria and viruses can't use it. It's like, oh, now that makes so much more sense why that happens when I fast.
Yeah. And, and the fact that there are many, many, many different kinds of particulate sizes and different kinds of LDL. And it matters what kind those are. And it's not that those inherently are bad for you. They're causing harm. They're sort of the smoke as opposed to the fire. They come about from damaging yourself from glycation. And so when you have carbohydrates, you have excess glucose or even fructose, this can glycate, which is a non-enzymatic fusion of these sugar molecules to other molecules. So this is a pathological function. Like, it's not something that we do ourselves or that we want to do. So this happens, just sticks to different molecules and messes them up and damages them. And that's what happens to these other LDL molecules, and it puts them into, makes them into small, dense lipoproteins. And those have a stronger association with heart disease, but there's still no evidence that they cause heart disease. So what I think is this is what a lot of people say, it's not just me, is that this is a larger inflammatory process. And this is a product of that inflammatory process, is this damage to this LDL cholesterol that's also damaging a lot of other things, that's also causing a lot of inflammation and damage to the rest of your body, that then precipitates atherosclerosis. So the reason that there's an association is because both things are being caused by the same process. And that is much more likely to be the case. And certainly it's not a direct one-to-one LDL cholesterol to heart disease. We know that. I mean, that's a no-brainer. I mean, even people that still espouse the cholesterol theory of heart disease still have to admit that, because there are massive studies. There's two different studies in the U.S. where over 140,000 participants in the U.S. who had a heart attack, and 50% had high cholesterol, 50% had low cholesterol, literally straight down the line, 50-50. And so it wasn't even like, well, it was like a 2% increase. No, it wasn't anything. It was completely not associated. And even if you have an association, even if it's a strong association, you can't prove causation. But if you have no association and you have pretty strong reason to say there's no association, like 140,000 people where there is absolutely no association, well, that actually proves that there's no causation, because you have to have an association if you're going to cause something, right? And what's more interesting is that those patients were followed up 2 years later, and the ones that either maintained a low cholesterol or reduced their cholesterol from high to low were 2 times as likely to have died in the intervening 2 years of follow-up. And the people that continue to have higher cholesterol, they were half as likely to die. So, we know that it's not just one-to-one. Cholesterol goes up, heart disease comes out. We know that, okay? But at the same time, people are still saying, oh my God, your cholesterol. Well, if we know it's not causative, if we know there's not a direct relationship between just your number of cholesterol and heart disease, then what are you saying is the mechanism here? I mean, that no one really answers that. They just say, right, here's a statin.
And that was going to be my next question for you is, well, here patient, here's a statin. And let's kind of noodle through this a little bit, but if our brain is the fattiest organ in our body and we're altering how our body metabolizes fat, cholesterol, wouldn't it make perfect sense that we would have problems with cognition? Wouldn't it make perfect sense that if LDL is part of the immune system, that we have problems with infection, which is one of the side effects? It all just falls into place. These aren't weird side effects. These make perfect sense.
Well, but that's it. And as someone said to me before, there are no side effects. There are just effects. Some of them you want, some of them you don't. But this is what this drug does. And what that drug does is it reduces a molecule in your body that is actually very important and has a lot of functionality and effects in your body that you don't actually want to get rid of. And so people can have a lot of side effects, and they say they mitigate that because they say, well, you're getting these problems, but at least you won't get a heart attack, or you'll be less likely to get a heart attack. And that's actually not true. The studies are actually showing that. There was a study with over 60,000 people over the age of 65, which are the highest risk group of getting heart attacks, and they found that the ones with higher LDL cholesterol were either had no increased risk, or sometimes actually a decreased risk if they had higher LDL cholesterol and were not on statins. And then the ones with statins had a slightly increased risk, and the ones that had low LDL cholesterol and on statins, they were at the highest risk. So that's doing the exact opposite of what this is proposing to do. And so the conclusion of this, the authors were saying, hey, look, we really need to rethink the role of statins and the role of cholesterol in heart disease, because at the best that we can say with this data set is that statins don't provide any benefit. And the worst we can say is that they're actually causing harm. And that would make sense if you understand that cholesterol is not a direct cause of heart disease, and it is actually a molecule that's really good for you, and so you don't actually want to reduce it. If you reduce it, that's going to cause harm, and it's not going to save you from heart disease.
When you start thinking of these studies like you're showing, where it's not helpful and it may be quite harmful, it's like, well, then why is the push for this? Why do all insurance companies push this? And I certainly don't want you saying anything, because again, for the listener, he's in a different country. We don't want to have him say things that would cause problems for him. Let's put it that way. And we'll leave it at that, because there are other things that he can't talk about that may cause problems. And we're not broaching those subjects at all today. But who stands to benefit, right? If insurance, like say in America, if I don't get good scores from my insurance company, if I accept insurance because all my patients aren't on statins, well, I can't open their mouth and jam a pill down their throat. So what's the point? Like, why are they pushing these so hard? I don't have an answer. I don't know if you do.
Oh, the statins. Well, I mean, statins have been the most successful drug that's ever been brought to market. It's brought the most profit and the most, just gross income of any group of medications ever in history. And if they keep, rolling this, down this path, it's going to just continue to give more and more and more and more back, because if we're still telling ourselves that cholesterol is the end all be all, anyone getting into their 30s, like, oh my goodness, you've got some high cholesterol, better get on this statin before the atherosclerosis builds up or even gets a chance to, they're going to have, billions of people for the rest of eternity on this drug that they can just keep, minting, fortunes off of. But, so that's their incentive. But, and if it were actually helping people, I wouldn't mind that. But I think the evidence is quite clear that we got that one wrong. And, the Journal of the American College of Cardiology themselves actually published in 2020 a large meta-analysis looking at all the available data and concluded that, saturated fat is not a problem. Saturated fat is not a risk for heart disease. There is no upper limit on the safe amount of saturated fat that you can eat. And in fact, they found an inverse relationship between saturated fat intake and stroke risk. Okay. So they found no association. Remember, if there's no association, there is no causation. So they found no association throughout all of the literature between saturated fat intake and heart disease. And they found an inverse relationship between saturated fat intake and stroke. So the less saturated fat you eat, the more likely you are to have a stroke. The more saturated fat intake you have, the less likely you are to have a stroke. And there's studies looking at Alzheimer's, dementia, Parkinson's. As you would expect, your brain is made out of fat, saturated fat, and cholesterol. And that having higher saturated fat intake, higher LDL cholesterol, the so-called bad cholesterol, is actually protective against all of these neurodegenerative processes. It's even it's even protective against. It seems to be a protective link between saturated fat and LDL cholesterol and autism. In fact, pregnant women who have higher intake of saturated fat and higher LDL cholesterol during pregnancy have lower rates of children with autism, which is getting out of control now. I mean, the rates of autism are skyrocketing. As with all these other chronic diseases that we are seeing and facing over the past 40 years, they've all increased dramatically. We revolutionized the way we ate. We said that cholesterol was bad, saturated fat causes higher cholesterol. This all exists in meat. Stop eating meat, stop eating eggs, eat more fruits and vegetables. And people listened. In America alone, we reduced our fat intake by 30% and cholesterol as well, reduced red meat by 33%. You just sort of switched over to chicken, lean chicken sort of things. And then increased fruits and vegetables by 30 and 40% respectively, and also grains and sugar as well. And what happened? The obesity rate tripled, heart disease tripled, stroke rate tripled, cancer rates tripled, type 2 diabetes, autoimmune disorders, Alzheimer's, Parkinson's, even neurodegenerative developmental delays such as autism, all increased exponentially. They almost didn't exist before then. Now they're the only things we treat. And they all increased at the exact same time. And they're still increasing. And we are still pushing more and more and more away from fat, away from meat, and into plants, into seed oils, going more vegan, going more fake meat. And so we're seeing exactly what you expect, if that theory is true, that we are going further away from our naturally evolved species-specific diet, our designed diet, our designed biological food source. And just like the animals in the zoo, just like the ducks at a park, if you feed us something that we don't normally eat, we will get sick. And that is exactly what's happening. And so that sort of shows that relationship that we're eating the wrong thing.
Again, from a religious background, I look at this from a different light, because it seems like, oh, there's some conspiracy to do this. No, there's not. There's a thing called the unseen realm. And so, our fight is not against flesh and blood, but against rulers and principalities of darkness, and in this unseen realm. And so what that means in the Bible is that there are these beings, you can call them demonic beings if you want, but what they do is they want to destroy God. Satan, he wants to he can't strike at God. There's nothing he can do to God, but he can destroy humanity. and that gets to God. And so how does that work? Well, there's a whispering of the ear. Oh, eat this. This is better for you. When in reality, it's worse for your body. It's worse for the planet. And it leads you to a point where you're so vitamin deficient that you don't know you're having neuropsych issues like B12. B12 deficiency, where there's no plant that has B12 in it, it can look like schizophrenia.
Yeah, and there's even a book that came out from Harvard psychiatrist Dr. Chris Palmer, who wrote a book called Brain Energy, and he's been doing research for years now, looking at how diet, specifically the ketogenic diet, affects schizophrenia and other psychiatric issues, and he's come up with this underlying unifying theory of psychiatric disorders, that it is a metabolic mitochondrial disease, which we're finding that a lot of diseases like diabetes, like cancer, like a lot of different diseases that are so-called chronic diseases, they actually come from a dysfunction of the mitochondria because we're eating the wrong thing. And we're damaging our mitochondria. They aren't working as well, and they can't generate ATP properly, and they can't move around the cell. It's quite interesting because, as he explains in the book, mitochondria actually move around on these little cytoskeleton sort of A trains. And you have hundreds of these things, thousands of these things in your cells, over 1,000 if you're healthy, and they'll go to a certain area and they'll make ATP right there, release that of that area, and that will spark something to happen in that area. Neurotransmitters to be released from that area right there, and then they'll go to another area. And so this is all carefully coordinated. When that breaks down, that can't happen as quickly, that can't happen as efficiently. They're not getting the ATP out in the abundance and timing that they need to, and that will just cause everything to go wrong. I mean, you have anywhere from a few hundred billion cells to several trillion cells in neurons in your brain, and they have 20 to 30,000 different interconnections with other cells. And so even just a little bit going wrong with that extremely intricate dynamic in hundreds of billions of cells, you have a major problem. This is the most finely tuned precision instrument that we know of in the universe, and it can go very, very wrong. And that's why I tell people that like the last 5% of going to a carnivore diet, a biologically appropriate diet, confers about 95% of the benefit, because even just a little bit of sand in the gears in a precision watch, it's done. You don't need to dump the whole, sand lot in there. It's just like a little bit will do it. And so because you've tinkered with this precision instrument, it's going to go wrong. And he found that people that went on a ketogenic diet, they were actually curing schizophrenia, bipolar, OCD, major depression, anxiety in far greater numbers than any of the standard of care. Near complete recovery in most people. There was a study done by Georgia Eade with 32 psychiatric patients that were inpatients. They were refractory to standard of care medications. They failed, and they couldn't function in society, so they were all institutionalized. They were all put on a ketogenic diet. Every single one improved. None of them improved on the standard of care. Every single one improved on a ketogenic diet. That's 32 patients. But Chris Palmer has done this with hundreds and hundreds, and the guys at Harvard, and Harvard does a lot of good research, and they do a lot of bad research too. They're very, very plant-based, which is interesting because he's in Harvard, and this is where a lot of this, just plants are good nonsense are coming out, and because it's coming from Harvard, it's Harvard, of course, it's so great. And it's like, but thankfully people like Dr. Palmer and others are actually coming out with real research showing actual improvement in people's lives, and it goes against that. So I'm sure they're fighting an uphill battle in their own institutions.
What first turned me on to carnivore was I stumbled across Michaela Peterson. Well, it was Jordan Peterson talking about Michaela, and she had idiopathic hypersomnolence is what he said, and which is interesting because I would just diagnose with that. Interesting. And which is super rare. It's like narcolepsy, but even more rare. And the difference is you go into REM versus not going into REM. And I was in Alaska at the time, and being a doctor, being on call, having narcolepsy your entire life, but now you're in Alaska, so you're standing in quicksand. It's like always being in jet lag. You have 2 minutes and 30 seconds of daylight change every single day. So it's either all day, all night, or you're always somewhere in between. And none of the medications were working. And so I started doing carnivore. I just switched 1 month, and I could stay awake. I could read to my kids at night and not be falling asleep with a book in my hand. And it was just shocking. And now, if I have carbs, I get tired. It's striking how quickly I can get tired from just a little bit of carbs. Like even fruit, I really have to stay away from carbs so that I don't. And it's not like Deuce Bigalow where you just fall asleep in your soup. It's not like that. It's but just that feels like you've been up for 48 hours. It just kind of overwhelms you.
Yeah. Well, I mean, if you think about it biochemically, when you're in, I'm sure you took biochemistry, is required for pre-med in America, and yet a lot of doctors in America seem to miss this simple fact that when you're in a so-called fasting state, your body works way better, and you produce carbohydrates, you produce glucose and glycogen and ketones, and that's much more efficient to actually store energy in fat and then use it later as you need to, and as opposed to just keep feeding the beast, a whole bunch of carbohydrates and just this quick burning fuel that you have to keep going with. That doesn't really make sense, and so I don't think that is a fasting state. It also doesn't make sense as a fasting state because I can eat 3 pounds of ribeye and still be in a fasting metabolism. That's clearly not a fasting metabolism. That is just a metabolic state that we are primarily in when we're eating our primary food source, which is meat. And that the so-called fed state is a pathological state, defense mechanism that our body's defending ourselves against hyperglycemia, which is dangerous because of this glycation that I mentioned earlier. The higher your blood sugar, the higher the rate of glycation, and this damages you. This can kill you. This is what kills diabetics, and your body recognizes this and puts up your insulin as a defense and tries to get this out as quickly as possible. But it's not, well, we're just going to titrate this down slowly. It says, no, we need to get this out now. And so it really slammed up your insulin quite high, and it has a long half-life. And so it stays up, and your blood sugar is now too low, and you feel wretched. And then you have to keep eating carbs to keep feeding that engine because insulin blocks lipolysis, it blocks proteolysis. So now all of your fat stores are shut down. You cannot mobilize energy anymore. You cannot make glucose, glycogen, ketones. You can only run on the blood sugar that is now coming down precipitously. And so you have to keep eating carbs and keep eating carbs and keep eating carbs. And I don't think that that's our primary metabolic state. In fact, that is not the primary metabolic state of humans in the wild who just eat meat, like the Inuit, and or like other animals in the wild. 66% of animal species are carnivores. They're all in this ketogenic starvation state, as they call it, but also herbivores that eat fibrous plants. They are able to break down fiber. We're not able to break down fiber. That's another reason that we're not supposed to be eating this stuff, is because we can't do anything with it useful. So animals that are herbivores that eat fibrous plants, they can all break down fiber, but they break it down into short-chain fatty acids because it's the bacteria that eat the fiber. No vertebrate animal can break down fiber. So the bacteria break it down, and as a waste product, they produce short-chain fatty acids, and then the bacteria die off, and that's also broken down and absorbed as protein. So what the animal is actually eating is different from what it's absorbing. So it eats a bunch of fiber, and it absorbs fat and protein. So even a cow or a gorilla is just eating green leaves and occasional fruit. They actually eat more green leaves than fruit. They're actually getting 70 to 80% of their calories from fat. And so they're all in a ketogenic starvation state. And we've actually tested this in wolves in 1981. There was a study. They said, well, you need carbs to burn carbs. That was the thought of the day. And so, but we don't see wolves, carbo loading before they chase caribou for 10 hours. So okay, do they have blood sugar? Do they have glycogen? And so they found out, yes, they do. And it's rock solid. It does not change no matter what they're doing, no matter what point that they found them, whether at rest, when they're in the chase, after the kill, after they've eaten. It didn't matter. It was right here because their body was constantly replenishing it from their fat stores. That is a much more efficient way of doing things than having to run. Okay, I need to eat a power bar, and then I can keep chasing this guy. Okay, all right, now I can go. That doesn't work. That just doesn't work in the wild. And so I think the only reason that we call that fed state and this a fasting state is because by the time we were able to look at biochemistry at a molecular level, everyone was eating carbohydrates. And so I said, when you eat it looks like this. When you don't eat it looks like that. It's like, yeah. Well, okay, when you eat anything except carbohydrates, it also looks like this. And you're not fasting. You have just eaten thousands of calories. So you're not fasting. Okay, so that's just your normal
I want to take you back to
state. Something
about the cancer. And I caught some of your Instagram live feed yesterday. And, I think I know the answer to this, but I'm going to ask you anyway, just because I want to make sure everyone else knows the answer to this. You were talking about cancer and how it's a common pathway, and you alluded to this, but so are you saying that all cancer's a metabolic issue that could probably be refined down to mitochondria?
That seems to be, what the biology certainly suggests. Excuse me. So, that's not me saying that. There's some of the top, excuse me, some of the top cancer researchers in the world going back 100 years. These are their conclusions. And so if you look at cancer biology, look at the work of, Nobel Prize winner Otto Warburg. He wrote a paper in 1951 called The Origin of Cancer. And he talks about how this comes from the mitochondria. This comes from damage to its ability to go through oxidative phosphorylation. And when it does that, it has to go through a substrate level fermentation process. A lot of, big words for a lot of people that they're never heard these things before. What that means is the mitochondria are damaged and they're not able to create ATP properly. And so they have to go through other means of energy production because the cell needs to make energy. So the problem with this is that there are a lot of downstream effects of this. It can create a lot of free radicals. It's less efficient, so you need a lot more glucose. And it causes a lot of free radicals that can hit around, bouncing around, damage cells. It can cause DNA damage and mutations. It also upregulates, and through epigenetics, it starts changing the genetic expression to start opening up the channels and start hosing in more glucose because they're like, hey, we need more glucose. We're not getting enough ATP with this level of glucose, and we can't run on ketones anymore because once those mitochondria are damaged to a certain extent, they can't run on ketones. So they can only run on glucose and only in the level of this cytoplasm, or they can also, some of them can run on glutamine. And so they can run on those sources, but they can't run efficiently. So they have to open up these channels and have to pull in a lot of glucose and glutamine. It could stop there, except for the fact that the mitochondria do a lot more than that. The mitochondria are actually what control apoptosis, program cell death. So when things are going radically wrong and the cell just says, no, we just gotta exit right here and let the rest of the boys go on, that doesn't work if your mitochondria are damaged and destroyed. So they can't do that anymore. And then further than that, the mitochondria are actually what regulate cell division. So they can't stop the cell from dividing at inappropriate times if they're damaged and they're not able to go about their normal business. So what is cancer? It's unregulated cell growth. And that's exactly what happens when you destroy the mitochondria. And so what we see in mitochondria in the cancer cells throughout every single cancer cell is there are these damaged mitochondria. There's something different about them. There's more of them, there's less of them, and they're physically, structurally different. And, in cell biology, structure, begets function. And so if the structure is damaged, they will not have the same function. And so you will see these damaged mitochondria in every cancer cell. And you will also see that all these cancer cells, as Otto Warburg showed 100 years ago, and people like Professor Seyfried at Boston College, formerly at Yale, have showed subsequently that cancer cells roughly require 400 times the amount of glucose to operate than normal cells because they're not as efficient at it. So they need a lot more of it. And they go through, this fermentative process, basically like anaerobic activity. Instead of getting a 36 ATP, you're just getting 2. And so you need a lot more of this stuff. And they're they're biologically more active as well. So, they need more even because of that. And so, so that gives you a good idea that this is from the level of the mitochondria, right? And another few things to consider, the other idea is the somatic theory of cancer, which is that this all comes down to the DNA, because that's what happened. Watson and Crick discovered DNA after Otto Warburg discovered all this about the mitochondria and cancer, and everyone just basically forget what everybody ever said. It's all about the DNA, because they figured this is it. This is the code for life. This is where everything comes from. And forgetting, first of all, that mitochondria have DNA. And second of all, that other things can have structure and function. And yeah, exactly. And so, and the mitochondria have actually implanted, its own DNA into, the nucleus and things like that. But there's still, many genes in mitochondria as well. And they have epigenetic effects on the nucleus as well. So it's much more complicated than that. But that was what happened. So basically everything got overshadowed because we discovered DNA, everything's DNA. Well, no, it's not. That has a lot to do with a lot of things, but that's not the end all be all. And some things that you can look at that sort of disrupt the somatic theory of cancer is that, first of all, cancer cells don't all have the same genetics. They're not all monoclonal. That's actually what I was taught in medical school. And, it was like you have this mutation, you get this mutation after mutation after mutation, you get these 8 different mutations that are hallmark of metastatic cancer. And then it just starts growing out of control. And that makes this big tumor, and that spreads throughout your body. But that's actually not true. Like you can take a tumor and you can cut it up and look at it in a microscope, and you will see every single cell actually visibly looks different, and they all have different DNA as well. And so they all act as cancer. They all behave as cancer. They're all malignant cells. And so that's a bit off. And some cancers actually don't have any genetic changes. None. So what's that about? And they come up with all these different weird theories, like, well, the microenvironment around it, maybe that's encouraging that to act as cancer. Like, well, you can sort of try to fit in different theories, but what it isn't is a genetic change in that nucleus, right? And so that's something right there. Another one that's very interesting is actually from direct test. They've taken, it's called like a mitochondrial DNA transfer studies. So they've taken the damaged nucleus, the damaged DNA out of a cancer cell and put it into a normal cell with normal cytoplasm and mitochondria. It does not behave as cancer. They could even clone frogs and rats out of it. Okay? Then you take the mitochondria, the damaged mitochondria, put that into a healthy cell with healthy, normal DNA. It either dies on the spot or it turns into cancer. You cannot clone anything out of it. It'll just turn into a ball of cancer and die. And so, that's pretty significant. And if you take healthy mitochondria and you put that into a cancer cell, it suppresses the cancer. It stops behaving as cancer. Okay? Regardless of the DNA.
That's better proof for origin of cancer than what we have for proof of origin of viruses. But
yeah, I mean,
but that's really conclusive.
Pretty damn conclusive, right? Yeah. I mean that's QED as far as I'm concerned. I was like, well, that's what that is. And yeah, it is. And then a theory is only as good as what it's able to predict. And so you say, okay, well, if this is the case, and if this is a metabolic issue coming from the level of the mitochondria, okay, how do you attack this? You're going to have different approaches, right? So if you attack the energy source and you put someone on like a ketogenic diet, it would stand to reason, if this were the case, that if you suppressed your level of if you're of glucose and started running on ketones, that this would limit the amount of glucose available to the cell, and your cells would be fine. You'd be able to run well because your body can easily run on ketones because you have normal mitochondria, the rest of your cells. But since the cancer cell can't run on ketones, it's going to run out of energy. It's going to die off. And in fact, that's what we see in animal models, as well as quite a lot of human trials as well. Some cancers run more on glutamine. So like GBM, brain cancers, glioblastoma, about 70% of their energy comes from glutamine, and about 20% comes from the glucose from the substrate level, and maybe about 5% they get from a bit of oxidative phosphorylation. But even just putting people on a ketogenic diet or even a carnivore diet, there have been a number of case studies that have survived far past what you would normally expect. So a glioblastoma, especially like IDH wild type, there's a bunch of different molecular sort of signals that we look on these cancer cells to tell us sort of what the prognosis is. Sometimes it changes the chemotherapy sort of approaches that we use with them. And so GBM with IDH wild type is really the most aggressive. So these have about a 2 to 3 month survival from time of diagnosis with no treatment. With chemo and radiation, you're talking sort of 8-9 months. And if you're able to do surgical resection and get over a 95% resection, that can bump that up to 15 months to 18 months. Okay, so that's overall actually for GBM. Yeah, exactly. Yeah, but you do have to cut out parts of the brain because it's very invasive. It's not like a met. Like a metastases can go in and sort of form this ball and push the brain out, but GBM actually just grows into the healthy brain. So you actually have to take out healthy brain with it. You can't just shell this thing out like you can with a met. Met can be growing invasive into the brain as well, but GBM almost invariably is, and so you do have to cut out healthy brain. But there are a number of people that maybe they had something, an eloquent part of their brain that were like, well, that's not safe to take that out. Or maybe they could take out a little bit, but they had to leave, a lot of it there. And then they started, taking chemo and radiation, and were like, well, look, I've got, there's a gentleman in England, Andrew Scarborough, who I actually had on my podcast. I haven't released the episode yet, but he is a 10-year survivor of GBM wild type. And he's had no chemo radiation. He had debulking, but he had a lot of it in the motor strip, and so they couldn't touch that. They only took out half of it. And so there's a significant portion of the cancer cells left there. And, he started chemo and radiation, but as soon as he got his moleculars back, that this was wild type, which isn't really responsive to chemo radiation, he just said, well, I'm not going to waste my time with that. I'm going to look at different ways of doing this. So he sort of discovered that people were using keto and fasting to help fight cancer. And so he started doing that. He started working with people like Professor Seyfried and getting their ideas. And he's now essentially just doing strict carnivore. He was having a lot of seizures. He was on 2 different anti-epileptics. His doctors would not wean him off of these things. So he actually self-weaned himself off, which I do not recommend people to do. It's very dangerous. But he did this over 2 years, slowly weaning himself off, which is, very, very dangerous. But he was able to get through it. He's not having seizures, and his subsequent MRI is showing no sign of disease. And he's actually subsequently earned an advanced college degree, and is now doing human trials on a ketogenic diet with cancer patients, with GBM patients at Charing Cross Hospital in London. So, that's actually quite amazing. There are a number of case series. So there are actually major institutions in the U.S. that actually already use a ketogenic diet. Cedars-Sinai Medical Center, they actually use ketogenic metabolic therapies. That's what it's called, KMT. For their cancer patients, including their GBM patients. They published a case series with, I think, 15 or 16 different GBM patients as well as other primary brain lesions. And the ones that were able to stick to it all fared far better than the average. And in fact, many are still alive. And there are some that couldn't stick to it and they said, well, this is too restrictive. And so they came off of it. They all died within a year. It's actually quite sad to look at that and say, like, was your life that bad, eating this way, as restrictive as it was, that it was worth dying? and maybe, maybe they would have died anyway. You don't know, but it is quite coincidental that's what happened in all these cases. And there are even randomized controlled trials, small numbers, about 20 patients, but they all showed benefit. And so I've actually been able to present all of this information at our neurosurgical grand rounds and just explain the metabolic theory of cancer and show this evidence and show all the different tons of different case studies, tons and tons of case studies, and also case series and randomized controlled trials, but in smaller numbers. And so I presented this and said, hey, we get anywhere from 2 to 5 GBMs a week, right? Why don't we do a larger trial? Why don't we really, put this home? There's already this being done in Charing Cross in London. There's another one being done in I think Dunedin Hamilton in New Zealand. I was like, well, why don't we do another one? Maybe even do a multi-center approach and have it get a lot more clout in the academic realms, but with large numbers, and just see and just put this question to bed, whether it does or it doesn't. I just think it's important to find out.
Well, Dr. Chaffee, thank you so much for coming on and just blowing my mind. I'm hopefully this has made the listener just rethink everything, because it's just amazing. Where can people find you more?
Well, my main thing is my YouTube channel is just Anthony Chaffee MD, and that's where I do upload all my videos and things like that. And I do that also on Rumble. If people are on Rumble as well, all the same things will go up on there. And then Instagram is where I sort of coordinate things, and that's just again Anthony Chaffee MD, and I'll post when I'm posting different videos or doing like a live event or something like that. And then for people that like listening to podcasts, I have a podcast called The Plant Free MD that my interviews and videos that I put out on YouTube, I then obviously have in audio form for people that like to listen to that as well. So those are the main things. I have a couple other social media things, but they can all be found through those.
And did you mention a Patreon earlier, if people want to give you money to help hear you more?
Yeah, I do have a Patreon, and again, it's just Anthony Chaffee MD, and that's kind of fun. We're sort of making our own community there. We have like a Discord community group where everyone's able to chat and talk and support each other, which has actually been really, really helpful for people, and it's turned into a very nice community for people. And I do a lot more live events there as well. So I'll do sort of like 2 live events a week on Sundays for like tier 2 and above. I'll have like a live Zoom meeting where we'll answer questions and discuss topics, and then sometime during the week I'll have a general one for everybody as well.
Awesome. Well, if you like what you heard, please go support them. Go, like them, share them, let everyone hear them, because this is information that needs to be spread far and wide. And if we can help financially support you too, please do that. Right? When you hear something you like, when there's someone who's speaking truth that you want to hear more of, throw $1 their way, throw $5 their way a month. That way they can continue to do this mission to get you the truth.
Well, thank you. I appreciate that. And yeah, it's I have a day job. I don't do this for the money, but it really does take a lot of time, and it is sort of helpful. And at least it's a good feedback that people are getting some use out of it.
Well, thank you so much for coming on, and maybe I can twist your arm and get you to come back on again, because there's so much we didn't talk about.
Yeah, happy to anytime, man. It was a pleasure.
All right, thank you. Just a reminder for everyone out there, duty uniform of the day, the full armor of God. Let's all make courage more contagious than fear.